Functions, procedures, methods, subroutines, they all come in different shapes and sizes. You will hear one of these terms when studying a programming language, and they're all basically bundled up pieces of code that gets executed frequently in a program. For instance, if you have a program that wants to fill the screen with a bunch of characters, maybe for a game, you don't have to rewrite it when you need to do that. All you have to do is simply call it. That's how you use APIs 99% of the time, because you don't need to know the source of the routine to call it. I don't know what each instruction of the write character to screen function does, but I can always call it when I need to do that. So let's say we have a function that fills the screen with a character. So our name of that function is fill screen. And our parameters, the things we're going to call fill screen with, is maybe we want to fill the screen with a certain character, so we have our character parameter or argument. They're the same thing because they all just mean what you want to fill the screen with. So character, what you want to do the function with in general. So character, and then we want to fill it half of the screen, a third of it, a fifth of it, or maybe starting from here. So we would have our position parameter. So over here we have the name of the function, our function name, and over here we have the arguments or the parameter of the function. So let's say we are in our main function, and we've set up the characters, and we're ready to we're not just ready to play the game, but we've set up the characters and we have done initialization stuff. So I'll indicate that by dots, and then now we want to execute the fill screen function, and the way we do that in Intel x86 assembly is to use the call instruction. So we could simply write call fill screen. Now, if you were using a debugger, you wouldn't see the label fill screen. All you would see is some number, some address, because that's where the when you're going to load in a program, that's where the address is going to be. That's where fill screen is going to be located at. So we could say that our address is some hex address 0b 0d. So now when fill screen is executed, when you're going to call this routine, what happens now is that the execution flow will be redirected to the address where fill screen is located at, or in this case 0b 0d. Now fill screen will do its job. See, that's why you don't even have to know the source of the fill screen. You don't have to know what each instruction fill screen does. All you have to know is that fill screen will definitely fill the screen, and then the code of it is in here somewhere. Now after fill screen is done, we're going to have the return instruction. And basically what that does is it would return to the last location after the call. So let's say after the call you want to start the game. So you want to start the game, call play game. You want to start the game. So right after the fill screen method completes, the function would go back to where you once ended, and that's where you once left off, where you last left off, and that's the call play game instruction. Now when we're going to call the play game, it's going to now redirect execution flow to a different address and is going to play the game. And perhaps later on, when we're finished with that, maybe you want to call exit or something like that. We want to exit the game. Call exit because we finished the game, and then now the program wants to exit. So basically that's the gist of the subroutines in assembly and basically in all programming.